Hello, fellow problem solvers. So today we're going to be doing a problem from my country's team selection test from 2006, problem number 3. It's a very cool number theory problem. If you haven't seen anything like this before, I really invite you to pause and try to think, how would you even approach this for at least 20, ideally an hour, not more than 3 hours. And if you'd like to go live with us, pause for 5 to 10 minutes, or 15 minutes and try to think, how do I even approach this? Like, what is happening? The n times the square root of 7 of the fractional part of n? I need to prove this is bigger than this for every single n? I mean, come on. How is this connected to what's, like I don't know what this is about. What's happening? And I hope that you pause, because here's like the first step. Okay. Fractional parts are generally more difficult to deal with. So let me try to write things in terms of the floor and in terms of n. So let's say that n square root of 7, let's say its floor is equal to some k, just so we can have something to work with. Now this side is equal to, what's it called? N square roots of 7 minus k. Okay, now I must prove how, like, that this is bigger than, this thing with n, right? I need to prove that this is bigger than something that contains n. And to do that, my question for you is, what do I need to do? What needs to hold true between this? Now, like, what does this tell me about this? Is there something that needs to hold true? If n square roots of 7 is equal to k, what does that? Well, this means, by definition, that n square roots of 7 is greater than k and less than k plus 1. Right? It's as simple as that. That's what it means. Now, with this, can you pause for 2-3 minutes? Try to see if there's anything else. How would you push this? How would you connect this to this? K being an integer. And for me, okay, let me try to figure out what k is, because that's the focus of the problem. I need to figure out stuff about k to be able to have any sort of estimate over here. Okay, so I have n squared times 7 is greater than k squared, and this is less than k plus 1 squared. And now I have a k. So k squared is going to need to be such that 7n squared is between 2 squares. But can I say anything about k if I know this to be the case? Right? Does k have some properties that hold true that could then maybe give us some estimate as to what this might be? For example, okay, 7n squared is greater than k squared. But 7n squared is k squared plus something, right? And the question is, what is that something going to be? If I know that 7n squared is equal to k squared plus some x, and if I find stuff out about x, then I know I can estimate that I have this, square root of n square roots of 7 minus k times n square roots of 7 plus k is equal to x. And then maybe, this part, I can estimate, this, like this, I can maybe estimate, like when I divide, I can then maybe have some estimates over here, right? That's the sort of idea. The x can give me something. Maybe I can write this down in terms of x over this, and who knows, maybe that leads to somewhere, maybe not, but this is what we're going with now. We need to find a way to really justify the size of this in terms of n. And if you think about it, for us to do so, we need to justify the size of, this thing is increasing, and it seems like roughly we'd be able to play it with something over here. Maybe we can use the fact that this thing right here is less than or greater than some n square roots of 7 plus or minus 1, right? Now maybe we can justify this with only n in the way. Like for example, we could say that this whole expression is strictly less than n square roots of 7 minus k. And then this, we're going to have times something, so we're going to have k is less than n square roots of 7, 2n square roots of 7. And now that gives us, like this thing over here is, mind you, it's 3 over 2n square roots of 7. So now this part over here seems to be more interesting to that. I say it seems to be more closer to what we need to actually prove. And this seems to be the quick assessment. Now here I invite you, pause for the next 15 minutes and try to see, is there anything here that you can push together, try to combine and notice something, okay? And I hope that you've paused, and here's the next step. So what can x be? If you think about it, now this thing over here is going to be this, as long as we prove x is at least 3. If x is greater than or equal to 3, we're done with the problem. But what is x? X is a number such that 7n squared is k squared plus x. Okay, now what does this necessitate for x? Well, can x be 0? Well, it cannot be 0 because, also, mind you, x is, it's non-negative because of this thing over here, because n squared of 7 is greater than k, and so I'm like adding something to get to what's going on. I'm adding something to get to 7n squared, an integer, a non-negative integer, in fact. So x cannot be equal to 0 because then I have k squared as 7 times n squared, which would make 7 a square, which is not true. So, can x be 1? Is the next question. And I invite you, if you haven't already, pause for 5-10 minutes and try to play with this, move this. And the answer is, well, x, if it was equal to 1, I need to have k squared be congruent to minus 1 modulo 7, right? And that is impossible because the residues when you're modulo 7, if we have 0 plus or minus 1 plus or minus 2 plus or minus 3, if this is x, then x squared is 0, 1, 4, and 9 is 2. Similarly, x cannot be equal to 2 because that would necessitate k squared congruent to minus 2 modulo 7. Again, giving us a contradiction because such a k does not exist. That's an integer. So x is at least 3. So this is greater than or equal to k squared plus 3. And if you think about it also, just like n is equal to 1, it gives us a k that's equal to 2. And gives us an equality here. So, what does this tell us? Well, it tells us this thing over here is greater than or equal to 3. And now we have this is greater than or equal to 3. Or in other words, n square roots of 7 minus k, which is equal to the fractional part of n square roots of 7, is going to be greater than 3 over 2n square roots of 7, which is equal to 3 square roots of 7 over 14n, which is what we needed to prove. And that's the problem. It's not, the reason I really like this type of number theory is because at the beginning when you see this, you're like, what am I supposed to do here? How do I get n, like the fractional part of n times, like square root of 7 is irrational, like how do I even begin that? I don't know anything about it. It's just when I multiply by n, it can, act in a way that I don't know how to control. It's what's happening to it, right? There's a lot of question mark there. Induction would be like another idea, but how do you, like when you add a square root of 7 into the fractional part, Who's to say that doesn't break you? Who's to say that you're not at some point, that you're not at, say, 0.00001 minus the fractional part of the square root of 7, that this isn't your fractional part. And then when you add the square root of 7, you get a very small number, right? You could be very far off from this, and then the next time you can be very close to that. So that's not the difficulty with induction. If you figure out a way to do this inductively, please do let me know. And as always, thanks for problem solving.